Imagine a machine so massive it weighs 15,000 tons, the equivalent of 100 Boeing 747s. This was the Captain, the heaviest land vehicle ever built in the U.S., a 21-story Titan that moved more earth than the entire Panama Canal project combined. But on a quiet Illinois night in 1991, this invincible giant was killed by a $50 piece of rubber. A single burst hydraulic hose transformed 8,000 gallons of fluid into a high-pressure flamethrower, turning the pinnacle of American engineering into a $100 million furnace in just 6 hours. Why did the most powerful machine on Earth have a fatal flaw hidden in its very foundation? And why, after 26 years of dominance, was it simply left to be eaten by its own shadow? Today we're uncovering the rise and the fiery execution of the Iron Beast, a machine that was too big to save and too expensive to let live. Captain Mine, Illinois. September 9th, 1991, evening shift, 8,000 gallons. That's what was circulating through the captain's lower frame at the moment one hose failed under pressure. Not a catastrophic structural collapse, not a detonation in the main drive motors, not a geologic event in the southern Illinois coal seam below. A single hydraulic line ruptured, sent a pressurized mist of fluid across the surface of an electrical relay panel in the machinery compartment. And the relay did exactly what relays do when exposed to ignition. The fluid was already burning before anyone above it knew the hose had failed. The evening shift crew heard the machine the way they always heard it, through the ground, not through the air. The vibration registered in your boot soles 200 yards before the pit edge came into view. In the operator's cab, 7 stories above the lower frame, the ambient smell was the same. It had been every shift for 26 years. Hot machine oil, coal dust from the overburden, and that dry metallic residue that coated the back of the throat and didn't fully clear until morning. The captain had been running continuously since 1965. No holidays, no shutdowns beyond maintenance windows. The 8 crawler blocks sat still while the dipper worked. Each block 45 feet long, 16 feet high, each individual shoe weighing 3.5 tons. The boom extended 215 feet into the Illinois sky. One dipper cycle, 270 tons of overburden, lifted, rotated, released. The sound of the house rotating wasn't metal on metal. It was a deep, sub-audible pulse from the main ring gear, felt in the chest before the ears registered it as sound. The operator at the controls had no view of the lower frame. Between his position and the compartment where the fire started were multiple decks of steel, 6 to 7 stories of structure, and the continuous noise output of 30,000 horsepower. Nothing on his instrument panel flagged a problem. That's the nature of what happened. It wasn't a detectable failure. It was a hydraulic line in a sealed space, running adjacent to an electrical panel. That proximity was a design condition, not an accident. Over 26 years of continuous operation, the captain moved more than 3.5 billion cubic yards of overburden. The entire Panama Canal excavation, the failed French campaign, and the successful American effort counted together totaled roughly 1 billion. One machine, one mine, one county in southern Illinois. Fire crews from multiple surrounding counties arrived and positioned on a terrace cut into the pit wall, 25 feet below the lower frame, not at grade level, not above the burn, but below it, because no standard fire apparatus in Perry County could physically access the base of a structure that size. They worked from the outside of an industrial building, directing lines upward at a fire that had 8,000 gallons to sustain it. The boom remained untouched throughout. So did the dipper, the wire ropes, the gantry. Everything that gave the captain its visible size survived the night. Everything that gave it life did not. Marion, Ohio, 1962. Southwestern Illinois Coal Corporation signed a contract with Marion Power Shovel Company for a machine that had no precedent in the industry, not an upgraded version of an existing model, a new category entirely. Marion's previous largest build weighed roughly half of what this new machine would require. The new specification called for double the weight of anything the company had constructed before. That framing matters, because by 1962, Marion Power Shovel was not an unknown shop testing its limits. The company had been in operation since 1884. Its machines cut the Panama Canal. 24 shovels shipped to Panama between 1902 and 1911, one of them setting the world excavation record in July 1908. Its equipment worked the Hoover Dam project. Its shovels helped dig the Holland Tunnel beneath the Hudson River. By the mid-20th century, Marion employed 2,500 people in its Ohio facility and held a position in American heavy industry that its competitors spent decades trying to match. And still, the captain was something its engineers had never been asked to do, the question no one raised in the public record at contract signing. Had anyone confirmed it was structurally achievable? The 1960s were the peak of American coal optimism. Electricity demand grew every year. New coal-fired generating stations were going up across the Midwest on multi-year construction schedules, and Illinois coal seams, wide, horizontal, accessible, were a strategic asset to every utility company in the region. Southwestern Illinois Coal Corporation held a deposit near Percy in Perry County, where two separate coal seams lay at different depths beneath a thick cap of overburden. To work both seams economically, you needed a machine capable of stripping hundreds of tons per cycle and advancing the cut at a rate no existing equipment could approach. The arithmetic was straightforward: cost of the machine versus cost of mining without it. The numbers favored the monster. The Marion design team in Ohio spent 2 years solving problems that had no published solutions at this scale. The central engineering challenge was weight distribution. How do you move 15,000 tons across soft southern Illinois ground without the machine sinking into its own pit floor? 8 crawler blocks, 4 to a side, was the answer, not yet proven at this scale. The resulting ground pressure came out to 61.5 pounds per square inch. That is less pressure per square inch than an adult human exerts standing still. The paradox was resolved entirely through geometry. Spread the mass wide enough across enough contact surface, and something 15,000 tons heavy becomes, to the ground beneath it, almost negligible. Each crawler block attached to the lower frame through hydraulic cylinders, 66 inches in diameter, 16 feet 9 inches tall. Those cylinders required hydraulic lines running through the lower frame. The electrical control panels and related equipment occupied a 15 by 85-foot room inside that same lower structure. In the technical specification sheets dated to the construction period, those hydraulic lines and their proximity to electrical systems were designated under standard industrial classification. Routine components, interchangeable with catalog parts from any heavy industrial supplier. No annotation flagged the routing as a priority risk. Each decision had its own internal logic. Compact meant functional. There was no wasted space inside a machine the size of a city block. Marion shipped the 6360 to Percy in sections and assembled it on site at Captain Mine. The erection took 10 months. Hundreds of workers, welders, electricians, hydraulic fitters, crane operators, built the machine essentially around itself, each successive section requiring temporary support frameworks that were removed as the next level went up. On October 15th, 1965, the captain was commissioned. For those who stood at the machine that morning, the first operators, the mechanics, the electricians who would spend careers inside it, The captain did not register as equipment. It registered as a place. A three-man elevator ran 8 stories from the lower frame to the machinery deck. 9 internal stations were reachable by telephone. The operator could address the ground crew by loudspeaker and contact the rest of the mine by radio. Inside the machinery house, the smell on that first operational day was specific. Fresh industrial coating, unaged hydraulic fluid, steel that had never yet been heated by use. In Percy and the surrounding towns, Cutler, Redbud, Pinckneyville, the launch had been coming for months. Local papers had run the specifications through the assembly phase, and the numbers didn't mean much to most readers except in one direction. This machine needed people, and it would keep needing them. Coal families in southern Illinois operated on a multi-generational logic that didn't require explanation. The captain was the visible anchor of that logic, taller than any building in Perry County, unmissable from the county road. As long as it moved, the work was there. Nobody was doing the math on 8,000 gallons of hydraulic fluid in a sealed compartment next to live electrical panels. Captain Mine. Any morning between 1966 and 1991, at 5:55, 5 minutes before shift, the incoming crew gathered at the base of the captain. Not dozens, a handful. 1 lead operator in the cab at the top, 1 assistant, mechanics assigned to the lower frame, an electrician. For a machine weighing 15,000 tons, moving 270 tons of overburden per cycle, the human head count was almost absurdly small. That was the point. The captain hadn't been designed to employ people. It had been designed to replace them. The work that previously required multiple smaller machines and the crews to operate and maintain each one had been consolidated into a single structure and a skeleton staff. The consequence was something no one had formally mapped in the operational documentation. Almost everything critical about how the machine behaved, its particular sounds, its tolerances, the early signs of a system developing a problem, lived inside a small number of people's heads. When those people left, the knowledge left with them. The lead operator's cab sat at the equivalent of the 6th or 7th floor of a standard building. In front of him, a system of levers and panels controlling the dipper, the boom angle, the house rotation, the propel. Each cycle had its own rhythm. Dipper into the cut, load, lift, rotate, dump, return. The sound of house rotation from inside the cab wasn't mechanical noise in any ordinary sense. It was a low resonance that moved through the seat and the floor before it reached the ears. A physical event as much as an audible one. Experienced operators read the machine through their bodies as much as through instruments. An abnormal vibration, a change in the pitch of the main drive, resistance in a lever that hadn't been there the shift before. None of that showed on a gauge. It was transmitted through contact. That kind of knowledge had value. It also had a cost. Operators who had run the captain for 10 or 15 years became, in practical terms, the machine's memory. They were not interchangeable with someone qualified on a smaller unit. Replacing them meant a gap, sometimes months, during which the incoming operator was learning what the instruments didn't say. And the institutional pressure at Captain Mine was the same as at every high-output surface operation in Illinois coal country. Keep the machine moving. An unplanned stoppage cost the company thousands of dollars per hour in lost tonnage. Scheduled maintenance windows were negotiated, not absolute. The space between technically due for inspection and still running within acceptable parameters was routinely occupied. The captain didn't operate alone. Around it ran a complete ecosystem. Smaller Marion 5761 shovels picking up material the captain had deposited, loaders moving coal to the preparation plant, a rail line hauling approximately 150 cars of coal per day out of the operation. At peak output, Captain Mine was shipping close to 6 million tons of coal per year. For the towns within 30 miles, Percy, Pinckneyville, Cutler, Sparta, the mine was the economic center. 2 generations of the same family working the same operation was not unusual. It was the expectation. The machine determined what a Saturday night cost and whether the school district could afford a new bus. When the captain stood down even for a planned maintenance cycle, the towns felt it within a day. In 1989, 2 years before the fire, Arch Coal, which by then controlled the mine, conducted an internal equipment assessment. Records from the Illinois Mine Investigator's Office that year note industry-wide discussion of hydraulic system integrity in heavy stripping equipment. What specifically was assessed on the captain, and what conclusions were reached about the condition of the lower frame hydraulic lines, is not documented in any publicly available source. No corrective order appears in the accessible record. No modification to the hydraulic routing was logged. The machine kept running. The operators who retired from the captain before 1991 left without formal technical debrief. There was no institutional process for capturing what they knew. That was not negligence. It was the standard practice of the era. Tacit knowledge transferred vertically, in person, from one operator to the next, through shared shifts and proximity. When the chain broke, it broke quietly. The machine didn't announce what it had lost. It continued running, slightly less legible than before, to whoever was in the cab the following morning. On the evening of September 9, 1991, the operator on shift could hear his machine. He knew its rhythms, its outputs, its normal register of sound and vibration. What he could not hear, what no one in any cab on any shift had ever been positioned to hear, was the condition of a hydraulic hose 7 floors below him, inside a sealed compartment, behind the constant output of 30,000 horsepower. The hose had been running under pressure for 26 years. Captain Mine, September 9th, 1991, 8:17 p.m. The first indication reached the operator through his instrument panel, not through sound, not through vibration, a pressure reading behaving wrong. Below him, separated by several floors of steel structure and the continuous noise of the main drives, a hydraulic hose had already failed. The pressurized mist had already contacted the relay panel. The relay had already done what relays do. The operator did not hesitate. He took the elevator down. That detail matters more than it sounds. The 3-man lift that ran from the machinery deck to the lower frame was still functional in those first minutes. The fire had not yet reached the electrical systems controlling it. The operator rode it down through the interior of a machine that was already burning on one side of the same structure. Those who later reconstructed the sequence noted that the window between ignition and loss of elevator function was narrow enough that a different decision, waiting, assessing, attempting to isolate the fault from the cab, might have closed it entirely. He made the correct call without knowing exactly how correct it was. Fire departments from multiple surrounding counties received the call and arrived within the first hour. Their positioning tells the whole story of what they were dealing with. They set up on a terrace cut into the pit wall, approximately 25 feet below the lower frame of the captain, not above the fire, not at the same level, below it, because standard pumper apparatus could not physically access the base of the lower frame from grade. The machine's footprint and the geometry of the pit left no viable approach from the surface. They were fighting a fire inside an 8-story industrial building from the street, directing lines upward at a sealed compartment with no entry point that any crew could safely reach. The captain was too large to fight from the outside and impossible to enter from below while burning. The fire burned for approximately 6 hours. In that time, it moved through the structure in a sequence that engineers later described in damage assessments. The lower frame went first, hydraulic systems, electrical panels, control cabling, the drive components housed in the base structure, then the machinery house where the main electrical gear and power distribution equipment were located, then the connecting structural members between the lower and upper sections. The boom, 215 feet of structural steel, anchored at the gantry, was never touched. The dipper survived. The wire ropes survived. Everything that gave the captain its silhouette was still standing when the fire was out. Everything that had given it motion was gone. Arch Cole's engineering assessment after the fire used a phrase that appears in the documentation without elaboration: damage deemed too great to repair. No detailed cost breakdown was made public. No alternative restoration scenario appears in the record. The conclusion was reached quickly, which, given what the engineers walked through in October 1991, was probably not a difficult conclusion to reach. What the official record doesn't dwell on is this: the Captain was not the only machine of its class to disappear that year. In early 1990, Marion 5961, the second largest stripping shovel ever built by Marion Power Shovel, operating in Muhlenberg County, Kentucky, had been sold for scrap. The coal seam it worked had run out. The economics of moving the machine to another site didn't justify the cost of relocation, so it was cut apart where it stood. When the Captain burned in September 1991, it was already the last of its kind. 18 months later, it was also gone. Two of the largest land machines ever built in the United States disappeared within 2 calendar years, one scrapped for economics, one destroyed by a component listed in the original specification sheets as standard in industrial class. The morning of September 10th, the day shift crew at Captain Mine learned what had happened during the night. The response was not loud. People gathered in small groups near the gate and spoke in low voices. A few walked toward the pit edge and stood looking in the direction of the smoke, which was still rising. The shift supervisor stood with them. There was nothing for him to announce that they hadn't already understood. In Percy and Cutler, the news moved by telephone before any newspaper had it. By midday, it had reached most households that had any connection to the mine, which in Perry County meant most households. A few men who had been in the field the day the Captain was commissioned in 1965, who had been young workers standing on that site 26 years earlier, gathered that evening at a local bar and said very little. One of them, by the account of people who were there, set his glass down at some point and walked out without saying goodbye. Nobody that evening was thinking yet about what came next. They were still thinking about what had just ended. Captain Mine, October 1991. Arch Coal and Marion Power Shovel Company sent their engineers to the site at the same time. They walked through what remained of the lower frame with clipboards and cameras. The metal around them still held residual heat, not enough to be called warmth exactly, but enough to come through the soles of heavy work boots. The smell was burned hydraulic oil, carbonized electrical insulation, and that particular metallic aftertaste that appears when steel has been held at extreme temperature for hours and is slowly returning to ambient. The structural members of the lower frame were intact. The steel had not melted, but everything mounted to it. Every panel, every cable run, every hydraulic component, every control system had been reduced to material that no longer had a function. The cause of the fire was not in dispute. It had been established within days of the event: a ruptured hydraulic hose, an electrical relay, ignition of pressurized fluid. What the joint assessment was actually evaluating was a different and more consequential question. Not what happened, but what, if anything, came next. That answer came quickly, too. Arch Coal's internal documentation recorded the conclusion in 5 words: damage deemed too great to repair. What that phrase compressed was a calculation that had very little to do with the fire itself. 1 year before the Captain burned, the United States Congress passed amendments to the Clean Air Act. Among their provisions were strict new limits on sulfur dioxide emissions from power plants. Illinois coal was high sulfur coal, not marginally, significantly. Utilities across the Midwest ran the numbers. Invest in expensive scrubber systems to continue burning Illinois coal, or switch supply contracts to low sulfur coal from the Powder River Basin in Wyoming and Montana. Most of them chose Wyoming. The switch didn't happen overnight, but the direction was already clear by the time Arch Coal's engineers were walking through the burned lower frame of the Captain in October 1991. Between 1990 and 2000, Illinois coal production fell from 61.7 million tons annually to 33.5 million. Industry employment in the state dropped from roughly 10,000 workers to fewer than 3,500. The fire at Captain Mine did not cause that collapse, but it arrived at exactly the moment when the economics of restoring a $100 million machine to work a market in structural decline made no rational case for itself. The industrial context turned too great to repair from a difficult decision into an obvious one. The restoration cost was never made public in specific terms, but the variables were not abstract. The original construction of the Captain in 1965 had cost approximately $15 million, equivalent to somewhere between $90 and $100 million in 1991 dollars. Rebuilding the lower frame systems from scratch would have required not just component replacement, but partial redesign. Significant portions of the original technical documentation were no longer in active circulation by 1991, and several custom manufactured components had not been produced for years. There was no off-the-shelf path back. Arch Coal sold the machine as scrap. United Salvage Company of Illinois received the demolition contract. At scrap rates for structural steel, 15,000 tons represented a substantial return, not enough to offset the machine's original cost, but enough to close the ledger on a capital asset that had produced for 26 years and was no longer viable. The company that had built the Captain was itself already in the process of disappearing. Marion Power Shovel had been absorbed by Dresser Industries in 1977, 14 years before the fire. By 1991, it operated as a subsidiary, not an independent entity. In 1992, while the Captain was being cut apart in the pit at Percy, Marion passed to Global Industrial Technologies. In 1997, Bucyrus International, Marion's oldest and most persistent competitor, the company whose machines had competed with Marion's at work sites across the 20th century, purchased the Marion assets for $40.1 million and immediately closed the manufacturing plant in Marion, Ohio. After 113 years, the factory that had built the machines that cut the Panama Canal, that had assembled the Captain section by section, shut its doors. The drafting tables, the manufacturing floor, the production equipment, gone. In 2010, Caterpillar acquired Bucyrus. The name Marion ceased to exist as anything other than a historical reference. The workers who had operated and maintained the Captain did not receive a single collective notice. The process of displacement was gradual and distributed. Some transferred to other Arch operations in the region, while those operations continued. Some found work at other Illinois mines, but the region was contracting faster than individuals could relocate. Gary Bartolotti, who worked in southern Illinois coal for nearly 3 decades and later served as mayor of the town of Christopher, described what followed in terms that didn't require industrial data to understand. All these towns were built around the mines. Our economies were completely dependent on them. Nothing else was happening here. In Perry County, the unemployment rate in certain areas exceeded 16% by 1993. Percy had no secondary industry to absorb what the mine had employed. The machine had been the town's logic, and when the machine was gone, the logic went with it. The scrap checks cleared. The engineers drove back to wherever Arch Coal's regional offices were. In Marion, Ohio, the lights in the factory stayed on for a few more years before they didn't. Captain Mine, 1992. United Salvage Company of Illinois began work. They cut the Captain apart in the same pit where it had operated and where it had burned. There was no alternative. The machine couldn't be moved intact, and no portion of it was structurally separable without demolition equipment. The cutting torches ran along steel that had been moving 270 tons of overburden per cycle 8 months earlier. A single dipper tooth, roughly the size of a standing adult, was detached and set on the ground beside the lower frame, and it sat there in the southern Illinois dirt, looking like something from a different scale of existence that had briefly, accidentally, been placed at human level. The expectation for anyone who had followed the story of the Captain would be reasonable, that something would be kept: a bucket, a crawler shoe, a nameplate at minimum. These were not unusual gestures. Museums, county historical societies, and mine operators across the Midwest had preserved components from significant machines as a matter of ordinary institutional habit. None of it happened with the Captain. No public memorial was established. No component entered any collection. The Illinois State Museum does not hold a piece of it. The Smithsonian does not hold a piece of it. 15,000 tons of American industrial history were processed as scrap metal over approximately 1 year, without ceremony, without announcement in the trade press, and without any formal record of conclusion. The most significant land machine ever built in the United States did not receive an obituary in a single industry publication. What Arch Coal did leave behind was land. The company transferred approximately 16,000 acres of the Captain Mine property to the state of Illinois. Today, that land is managed as a recreational area. Trails, lakes, fishing access, wildlife habitat, the terrain. The Captain, methodically inverted over 26 years, has been reclaimed to a profile that reads, at a casual glance, as natural topography: uneven, layered, cut through with water. A geologist would identify the pit geometry immediately. A fisherman pulling up to the boat launch on a Saturday morning in June would see a lake. The coal that the Captain helped extract had already done its work long before the machine burned. It had moved through preparation plants, rail cars, and utility contracts into decades of electricity generation across Illinois, Indiana, and Missouri. That energy is not traceable to a source anymore. The steel from the machine itself, 15,000 tons, sold through United Salvage, processed through regional scrapyards, was redistributed into new production runs without designation. There is no object anywhere that can be identified as formerly belonging to the Captain. Nothing behind glass, nothing on a plinth. The machine that outmoved the Panama Canal by a factor of 3 left no physical remnant in the world. Southern Illinois did not recover the economic position it held before the Clean Air Act amendments reshaped the coal market. By 2015, the state was producing roughly 91% of its 1990 coal output, but with 41% of the 1990 workforce. The productivity gains came from technology and from consolidation, not from restored demand. The jobs that had structured life in Perry, Franklin, and Williamson counties did not return in any equivalent form. New industry did not arrive to replace them. The towns that had been built around coal remained towns built around coal, except the coal was now worked by fewer hands on diminishing acreage, and the institutional gravity that had held communities together across 3 generations was no longer sufficient to hold them at their 1985 population. Christopher, Pinckneyville, Percy, Cutler, through the 2000s and into the 2010s, these towns carried poverty rates roughly twice the Illinois state average. School districts merged or consolidated to maintain basic services. County emergency services were restructured simply to remain operational. The social infrastructure that a 6 million ton per year mine had quietly underwritten, the diner that stayed open on the night shift, the hardware store, the high school sports program with a full roster, contracted without announcement. The way things contract when the reason they existed is gone, but no official event marks the transition. In Marion, Ohio, the factory that built the Captain closed in 1997 when Bucyrus International acquired Marion's assets and shut the plant. The building that had housed the drafting rooms, the production floor, the cranes that lifted machine components, it stood for years after closure as Marion, Ohio, worked through the same arithmetic that Percy, Illinois, had already completed. A company founded in 1884 that had shipped equipment to Panama before the First World War, that had built the machine that out-excavated all other machines in American history. It ended as a line item in a Bucyrus acquisition filing. When Caterpillar bought Bucyrus in 2010, the Marion name disappeared from every active document. Today at the Captain Mine recreational area, the fishing is good. The lakes are clean. In season, people drive out from Pinckneyville and Duquesne with rods and folding chairs and coolers, and they spend the afternoon at the water's edge without thinking about what the ground beneath them once was. The old rail spur that carried 150 coal cars a day out of the mine has been gone for years. The ties pulled, the grades softened by weather and grass. The Captain moved more earth than any machine in American history. It burned in 6 hours. It was cut apart where it stood. Nothing was saved. They don't build machines like that anymore. They don't build the towns that grew around them either.